Lesson 3, the ray model of light. In this lesson, we're going to start off by describing a ray of light, and then describing the field of geometric optics. We'll then define transparent, translucent, and opaque objects. From there, we'll look at some terminology related to geometric optics, including normal, angle of incidence, and angle of reflection. And then we'll look at some laws of reflection and differentiate between different types of reflection. Let's get started. If you've ever played around with a laser pointer, or if you've just seen a laser, you'll notice that the light from a laser travels in a straight line. And this important property of light is what allows us to study the field of what's known as geometric optics. In geometric optics, we use a light ray to determine the path of light when it strikes an object, such as a mirror or a lens. Mirrors and lenses are two objects that light interacts with that allows us to see. For example, mirrors reflect light, whereas lenses bend light. Lenses can be found inside of eyeglasses, microscopes, and telescopes. These devices allow us to change the path of light and form images where we desire. But first, a little bit of terminology. We'll start off with a light ray. We basically use a line with an arrow to represent a light ray, and this represents the direction and straight line path that light travels in. An example can be seen in the picture below. Let's say we had a luminous source of light, such as the flame from a candle. We treat that flame as a source of light, and if we model it using geometric optics, then that source of light gives off all of these light rays radially away in all directions, which are represented by these line segments with arrows. These light rays then travel outward until they either enter your eye or reflect off of another object and then enters your eye, which allows you to see objects in the room around you. With that being said, we're going to focus on three different types of objects that light can interact with. The first are transparent objects. These objects let light pass through easily, and as a result, it allows objects behind it to be clearly seen. Can you think of any examples of transparent objects? Imagine, for example, glass. In your house, windows. Next up, we have translucent objects. These objects only allow some of the light to pass through. You wouldn't be able to clearly see an object behind a translucent object. Some examples of translucent objects would include tinted windows, maybe in your house you have frosted glass. You can imagine wax paper that you use in baking. These are objects that allow some of the light to pass through, but you're not going to be able to clearly see what's on the other side. And of course, there's benefits. In the case of frosted glass, it allows some privacy in a house. And in the case of tinted windows, it does give the people in the car a little more privacy. And lastly, we have opaque objects. Opaque objects do not allow any light to pass through. And that's because all of the light is being absorbed. Or another possibility is that all the light is being reflected. And as a result, you cannot see any objects behind opaque objects. An example would be like a brick wall, let's say. Or in your house, the walls, so drywall for instance. These objects ensure that you can't see what's on the other side. So what we're going to do next is study some properties of mirrors. We're going to look at how light reflects in mirrors to create an image. But first, we'll need to define some terminology associated with mirrors. First of all, what is a mirror? Well, mirrors are just glass that have a thin reflective film behind it. Examples would be silver or aluminum, and we can see this in the picture below. So we usually use this diagram to represent a mirror. The straight line on the left represents the reflective surface. This arrow shown on the left would represent the direction of light. I'll just highlight it here to make it a little more clear. Okay, so that's the direction of light. And you want the reflective part to be on the same side that the light is coming from so that the mirror can do its job and reflect the light back at you. And then on the other side of the mirror, indicated by these dashed lines, we have the opaque side. Okay, so with that being said, a common mirror that you probably experience in everyday life is a plane mirror. These are mirrors that are completely flat. And this is probably most mirrors that you have in your house, for example, like bathroom mirrors, hallway mirrors, if you have a mirror on a closet door, for example. We know that mirrors form images, but consider this. When you're looking in a mirror, what you're seeing isn't really there. So for instance, if you look in a bathroom mirror, it appears like you're on the other side of the mirror, but you know in reality that there's really nothing there. We call these types of images virtual images. And these are images that kind of play tricks with your brain. Virtual images are what your eyes think they see, when in reality, that object isn't really there. So let me explain what I mean by what your eyes think they'll see. So in the image below, let's say that you're looking in a mirror. So on the left here, that would be you. And we're going to treat you as a source of light. So imagine that one ray of light is leaving the top of your hair like this. When that ray of light hits the mirror, it reflects off of it. So I'll draw the reflected ray of light in a different color. And it's that reflection that enters your eye. Let's look at another example. Say a ray of light coming from your chin is shown below. That ray of light reflects off of the mirror and enters your eye, which again I'll draw over with a different color. So in my picture, the blue rays of light are from the source, that's you, and the purple lines are the reflected rays of light. This is how a mirror tricks you though. Your eye perceives it like the rays of light are coming from behind the mirror, which are indicated here by the dotted lines. In reality, the light isn't coming from the other side of the mirror, but this is sort of the trick that mirrors play on you, making you think that the object is on the other side, and that's where the image is. So just consider that. The next time you look in a mirror, you're seeing a virtual image because it's not really there. Let's continue with some terminology, and I did use a little bit of this already, but the incident ray would be the original incoming ray. And in this case, that would be the ray that hits the mirror. In the picture above, I drew those rays in blue. The reflected ray would be the ray of light that bounces or reflects off of the mirror. And those were the rays in the picture above that I drew in purple. So I'm just trying to color code it to help you match. And one more thing I wanted to mention, I mean, clearly human beings are not a source of light, but what's happening is light coming from a source in the room is bouncing off of you and then reflecting off of the mirror. So in that sense, we're treating you almost like a source of light, but in reality, you're not. As you know, if you try to look at an image in a completely dark room, you're not going to see anything. You do need a source of light. One more bit of terminology is a line called the normal. This would be an imaginary line, and that line would be perpendicular to the mirror. So that means at a 90-degree angle to the surface of the mirror. And we typically draw it at the point where the incoming ray or the incident ray hits the mirror. Let's take a look at this in the picture below. So on the left, imagine that we have an incident ray of light. That incident ray of light is moving towards the mirror. When it hits the surface of the mirror, it's going to reflect. So that's our reflected ray on the right. And the dotted line, which I'll just draw over in red, is our normal. Okay, the normal is perpendicular to the surface of the mirror, indicated by the 90-degree angle below. All right, and hopefully that defined all of these new terms. Let's carry on. We need to talk about some angles now. First off, we define the angle of incidence to be the angle between the incident ray and the normal. And the angle of reflection is defined to be the angle between the reflected ray and the normal. Let's label these in the picture below. So it's the exact same image from the previous page. We have the incident ray on the left and the reflected ray on the right. And just to make it clear, I'll just highlight the normal. So the angle formed between the incident ray and the normal, which I'll just indicate here in blue, is defined to be your angle of incidence. Similarly, the angle between the reflected ray and the normal, shown on the right, which again I'll highlight in blue, that is your angle of reflection. And I'll just make one note, which can be a common mistake. Always measure these angles relative to the normal, not the mirror. And that leads us to a very important law in optics, the law of reflection, but specifically for a plane mirror. So let's take a look. The law of reflection tells us that for a plane mirror, that is a flat mirror, the angle of incidence is equal to the angle of reflection. Okay, so for a perfectly flat mirror, like so, all light should reflect off with the same angle that it came in at. The second thing we can take away from this is that the incident ray, the reflected ray, and the normal all lie in the same plane. That should be one line over there. So what do we mean by that? Let's take a look. Imagine if this rectangular box was a sheet of paper, then the incident ray, the reflected ray, and the normal all lie on that sheet of paper. That's what we mean by they all lie on the same plane. Okay, so hopefully that made sense, and now we're going to move on to different types of reflecting surfaces. So depending on the type of surface that we have, that's going to affect the type of reflection. The first type of reflection that could occur is specular reflection. This is whenever light reflects off of a smooth, shiny surface. Examples would be plane mirrors like we just looked at, as well as maybe even a very calm water surface. If you look at the picture below, all of the incident rays reflect off of the surface at the same angle that they came in at. So if I have several incoming rays of light that are parallel to each other, then when they reflect off of a flat surface, they're going to create parallel reflected rays. And that's because all of the angles of incidence and all of the angles of reflection are equal. And this is what allows you to form perfect images. So when you see a perfect image of yourself in the mirror, that's due to specular reflection. The next type of reflection is probably less understood, but equally important to seeing the objects around you. So before I go on, what I'd like you to do is look at an object in the room around you. For example, it might be a coffee cup, it might be the pencil you're holding, it might be the paper in front of you. Can you see your reflection in that object? And most likely you can't. And the reason is those objects aren't perfectly smooth, flat surfaces. But you're still able to see that object because clearly light must be reflecting off of it. So the type of reflection that occurs here is diffuse reflection. This occurs when light reflects off of an irregular or a dull surface. Okay, so examples would be paper like I mentioned, maybe a rough water surface with waves, a crumpled piece of aluminum foil, for example, etc. And the reason for that is as follows. That surface isn't perfectly smooth. If you zoom in and look at it, it's very rough with a lot of irregularities, maybe a lot of bumps. And as a result, for all of the parallel incident rays, they are reflected, but they're scattered. So these surfaces create scattered reflected rays. And that's because in this case, the angle of incidence and the angle of reflection are not the same. So don't be worried, we're not breaking the law of reflection. It's just that the law of reflection only works for those perfectly smooth, flat objects. All right, everyone, and that's going to wrap it up. So please try the following practice questions for homework. If there's anything you're not sure about, don't hesitate to reach out. Thank you very much, and we'll see you in the next video.